examples. This next one is just a little bit more difficult than the previous example, but that will only come at the very end. So let's take a look at how we solve this question, because again, all of these questions are solved in the same way. So we notice that it's a reciprocal of a quadratic. There is a negative sign out in front. And remember, you can write that negative sign out in front. You could write it at top with the numerator, or if you wanted to, you could write it on the bottom. I always like to place it on the top just to move it away from the front of my function. Let's go ahead and find the x-intercept. So the x-intercept is found by setting y to be 0. And we can see once again that when we multiply both sides by the denominator in this case, the left-hand side will still be 0, and we end up with 0 equals negative 1, which can't be done. So that tells us that there are not any x-intercepts, which we can move all the way down and write for horizontal asymptote at y equals 0. We can also take a look at the y-intercepts. And the y-intercepts in this question, again, are found by hiding or setting the x's to 0. Negative 1 divided by negative 6 is going to be a positive 1 over 6. And then finally, the vertical asymptote is found by taking the denominator only and setting it equal to 0. So we have 2x squared minus x subtract 6. This we will need to try and factor, which I believe the factors work out to be 2x plus 3 and x minus 2. And you can FOIL that back together. That will equal the original quadratic. From here, we do have two restrictions, so therefore two vertical asymptotes. The first one is located at x is equal to negative 3 over 2 when we solve for x, and the second one is equal to x is equal to 2. Remember, you're taking as many factors as you can, setting them each equal to 0 and solving for x. So let's go back to our graph and place those intercepts, or those vertical asymptotes. So there's one at x equals negative 1.5 or 3 over 2, and then there's one slightly to the right, a little farther away from the y-axis at x is equal to 2. So let's label both of those. X is equal to 2 and x is equal to negative 1.5 or negative 3 over 2. We do have a horizontal asymptote, so let's place that where it belongs at y is equal to 0. The other bit of information we know is there is a y-intercept located at 0 and, let's place that here, 0 and 1 over 6. Now this is a good example because wherever we sketch this, there's a very good chance that this y-intercept is not in fact the max or the min point of this middle section of the graph, but we'll get to that. We now need to sketch. Once again, use the method of end behavior, and so ask yourself the questions once again: what happens as x approaches negative infinity? So way out to the left. Let's go back up to our original equation. Again, if I plug in a really big negative value here, it's squared and it becomes positive. Then I plug in another negative value, and a negative times negative is a positive again. So I end up getting a very large positive number on the bottom. But if you recall, I have a negative 1 on top. So it's like I'm looking at negative 1 by a very large positive number. Well, the negative and the positive are going to make a negative, and it's getting infinitely close to 0. So I'm going to have a point along here. As I approach negative 3 over 2, I can take that same principle and say, as I'm moving along here, I either have to go up or down because I can't cross this vertical asymptote. There's a horizontal asymptote above, so this forces me to go down. I can use the same approach on the right hand side. What happens as x approaches positive infinity? Well, you'll notice when you substitute back in, you have a very large positive number squared, which makes it even larger. Subtract that number, which will affect it, but the larger values you plug in, the larger positive number, we will end up with the same aspect over here. And so we end up having the same approach. We travel towards that vertical asymptote. We can't cross it, so we have to travel down. And you'll notice that we have typically basically these mirror images on each side in reciprocals of quadratic. The last thing to do is to recognize what's happening in the middle portion of our graph, the middle interval. And once again, because there is a point here and I start moving to the left, I can't cross that vertical asymptote, so I just have to hug it going up, and the same thing occurs here. The difference is I'm not exactly sure that the y-intercept is my lowest point. So to do that, I need to find the vertex. It's going to be very close to that, but it's really tough to see on my diagram. So the way, once again, we find our vertex is we find the middle x value, which is found by taking this x value plus this x value divided by 2. And when you do that, we'll start to do that here. I have negative 3 over 2 plus 2 all divided by 2. This ends up being on the top 1 over 2. Negative 1.5 plus 2 is a half divided by 2. And when I invert and multiply, I end up with an x value of 1 over 4. Now that's the x value, and we're actually after the y value, how high up that is. So to get the y value, we plug it back in to the original function. So if we look back up, it was negative 1 over 2x squared minus x minus 6. Now, this is going to take a little bit of work to simplify this. So I'm going to move this over here so we can go a little bit larger. So to solve for that y value, I have negative 1. I need to enter in the 1 over 4 and square it and subtract it. I'm going to use some brackets there and then subtract 6. The next line, I'm going to expand it once again. 1 over 16 minus 1 over 4, subtract 6. And I'm going to continue. 2 cancels into 16 8 times, and I notice I have 1 over 8, so I could continue to write minus 1 over 4 minus 1 over 6, but I realize that I'm going to need to put both of these over denominator of 8 at some point, so I'm going to do it right now. So 2 over 8 is the same as 1 over 4, and 48 over 8 is the same as 6. By doing this, I can save myself just a little bit of work. 1 minus 2 minus 48 is negative 49, and when I invert and multiply, I end up with a positive 8 over 49, which on the calculator is very similar to about 0.163. And I notice that that is slightly lower than 1 over 6. And that will be my vertex. My vertex is going to be 1 over 4 and 0.163. Very close to what my y-intercept was. This will allow me to state my range now and domain. So I'll do that over here in green. So the domain, once again, if we look back up at the function, negative infinity to negative 3 over 2, from negative 3 over 2 to 2, from 2 to positive infinity. Negative infinity to negative 3 over 2, round brackets. Negative 3 over 2 to positive 2. The range, because we've done that work, we know it runs, if we look at the graph, from negative infinity up to 0, but not including it, negative infinity to 0, and also from that new minimum point of 0.163 to infinity. The last example we want to look at is a special example, and to do so we are going to go through the same procedures we always do. Find the x-intercepts. Well, when we set y to be 0, we end up with 1 over x squared plus 4, which very quickly becomes 0 is equal to 1. So there are no x-intercepts. This tells us, if we want to jump right to it, the horizontal asymptote is y equals 0. The y-intercept, there is one, and again, if we cover this up, we have 1 over get these answers fairly quickly now. And then we get to our vertical asymptote, and in these cases we've either had one vertical asymptote, or in the last few examples we've had two. In order for us to sketch this, we set the denominator equal to 0. But when we do that, we end up with x squared equals negative 4, which can't be done. We can't take the square root of a negative number. So when we are sketching this, this is what it looks like.